Good afternoon. How are we all doing today? So we are going on to Unit 11, Lesson 4, Page 1. So we did the second page yesterday. We're doing the first page today. Sierra, I did see it. All I'll say, Sierra, and I don't know if this is going to help now or if I'm going to have to talk to you in Zoom or through email. Just remember, cosine means the x value and sine means the y value. That'll help you answer questions 2 and 3. And then the very last one, number 4, is where you have to use the Pythagorean theorem like we did in the notes. So if you still have trouble with what I'm saying there, just like I said, I can write that in email, or I can do it. In Zoom or something like that. So we are doing Unit 11, Lesson 4, Page 1. We did this back page yesterday where we were doing conversions. So we were converting from degrees to radians, and we were converting from radians back to degrees. We had to go in both directions. We did a lot of math with that. And then the very last problem, we did the conversion to figure out what quadrant it was in. So today we're going to go more into just focusing on radians and using the small little formula that's inside of the box. So I'm just waiting a little bit. We don't really have that many viewers on right now from what I can see. But it's always delayed in showing the number of viewers. So that's why I'm just kind of waiting a second. Let me check the website. Sometimes when I go to the website, it shows me everybody that's in here, no problem. No, it's only showing that there's 5 people here. Oh well. Well, everybody else can go back and watch the video. So, be it. All right, so I'm going to go straight to the box. So the box says the definition of a radian. So it says the radian angle theta created by a rotation about point A using a radius of r and passing through an arc length of s is defined as, because obviously every single person that's going to read that knows what that means. It's theta is equal to s over r. Or if you cross multiply, s is equal to theta times r. So I'm going to do it as a picture so it makes more sense. So let's say that we have an angle. Just some random angle. And that angle is going to be called theta. Okay. Yes, Sierra. Because on that homework was using the unit circle. So that angle is going to be theta. This part down here, because we're talking about a circle, since we're talking about a rotation, this is just going to be the radius. We don't know how long the radius is because it's not given to us, so I'm just going to leave it as r. And the way this works is if you rotate this line around to that terminating angle, this line is going to be exactly the same as down there. It's still going to be the radius because the size of the line doesn't change when you rotate. Today we're going to be talking about a new piece, and it's this part out here. This is known as S. S is going to be known as something called the arc length. I have no idea why they use the letter S for this. Some famous mathematician chose to use S, I guess, so we'll just leave it at that. But S represents the arc length. So today we're going to be solving for either the angle in radians. We could possibly be solving for the radius, or we could possibly be solving for the arc length. So in general, I'm just going to kind of show you guys in exercise number 1, like a brief picture of what all of this actually is. Yeah, math people don't make sense at all. So what I'm going to do is I'm going to draw a circle. All right. Apparently my iPad doesn't want to draw a circle. Draw a circle. Okay. So we have a circle. This says, what is the arc length S of the rotation created? In other words, what is the total distance of the arc? So what I'm going to do is, all right, I'm going to put a center in this circle. And let's just say the center is P. Because I'm just calling it a point. So we're just going to call it point P. And we're saying that we have our radius. So this is just represented by R. So it's kind of similar to what I just drew up top, but I'm showing it to you guys in a circle now. Now, we can find the arc length based on where it ends. Okay? Now, they're saying in this one that they want us to consider a full rotation. So if we started at this original line R and we do a full rotation, we know how many degrees that's going to be. Because a full rotation just means that we're going to have 360 degrees. Okay? Now they want to know the arc length of this rotation. So this is what's different. So we've always found the angle. We're trying to find the complete rotation of the angle. Now we're trying to find the distance of that line. Now you guys were taught how to find a distance of a circle a long time ago. You may have done a little bit back in geometry, but this was really taught back in like middle school. You guys may or may not recall that in order to find the length of the outside of a circle, we used something that started with C. And I'm going to write down the formula first. It was C is equal to pi d. Or sometimes it is written out as C is equal to 2 pi r. And the reason why we're writing both of these out is because D stands for diameter. And if you guys remember your vocabulary from geometry, diameter is just two radiuses put together. So if I were to go all the way across, that would be a diameter. And it's 2 r's. So that's why those two formulas are exactly the same. The C stood for circumference. So what I'm trying to get at is everything that I'm about to do with you guys is really just finding a piece of the circumference. That's all that's going on. Okay? So I'm going to show an overall little formula here. The formula that we have written up top right here, this theta is equal to S over R. I'm just going to write this off to the side. And I'm going to focus on this part of the circumference because I can plug that in. That's my arc length. That was the distance all the way around the circle. So this right here is the same thing as S. So again, I don't understand mathematicians because some mathematicians will say that it's the letter S and some people say it's the letter C. So I don't know. Maybe S stands for the slice of the circumference. Maybe that's what it is. No, so Tabitha, you're talking angles. So we're not going to be doing angles today. We're just doing the sides. So what we're actually doing is just we're going to be doing a lot of finding this S. So if we were looking for the angle of the arc, then yes, then you're going to be doing some doubling. Sometimes it's equal. But right now, we're just looking for the distance. So like if we were to take a ruler and try to measure it out, we're trying to figure out how long it is. So now that that's S, I'm going to plug it in to this formula. So I have theta is equal to S over R for a full rotation. So if we were going to talk about the angle, the full rotation is 360 degrees. But we're not talking about the total angle. We're talking about the total distance. So now I'm going to plug in my new S, which is 2 pi r, all over S. I'm sorry, R. I wrote S, and it should be an R. The reason why I'm showing this out is because what we did on the back page yesterday is all being proved right here. It's being shown in this. Theta is represented by the angle. And if I were to solve for this angle theta, we're going to have 2 pi r over r. Those r's are going to cancel out, and we're left with 2 pi. 2 pi is the angle in radians. Yesterday, I taught you guys that 2 pi was equivalent to something, and it's the first thing we started off with yesterday. If theta is represented by the angle, and we were to do a full rotation, theta can also be equivalent to 360 degrees. This right here is what we did on the back page when we were doing our conversions. So 360 degrees and 2 pi mean the same exact thing. One is in degrees, one is in radians. Okay, so number 1 was just trying to show you guys that degrees and radians are exactly the same. They are no different. Okay. Now I'm just going to use the formula for, I got 2 questions for you guys because you're going to have 2 questions similar to this on the back page of the homework. In exercise number 2, it says if the length of the initial ray is 5 inches and rotates a total distance of 13 inches in the positive direction, then what would be the number of radians? So because I'm asking you guys to find the radians, what I'm going to do is use that formula that I just highlighted up top. So I have theta equals s over r. I have to wait for my iPad to work again because it's always so glitchy. Hopefully it doesn't crash. So this is the error I was getting last year. My whole iPad would crash and then it would erase everything that I wrote down. And it actually did it to the Math 12 students yesterday. I had it happen a lot last year and then it deleted everything on my iPad. So I'm hoping it doesn't do that again. But as far as this exercise goes, we just have to figure out where everything's going to be plugged in. So I'm going to draw it out and then we'll figure out where it goes in the formula. So it says we're starting off with the initial ray. And you know what I'll do? I'm going to do it like we did the last couple of days. I have my x and y axis. It says that the initial ray, that might be too thick. The initial ray is going to be 5 inches. So we started here, and that is going to be 5 inches. So it's not exactly like what we did the other day because we're not necessarily working with a unit circle this time. Nowhere in this problem says we have a unit circle. They're giving us actual dimensions. So we're starting with 5, and it says that we're rotating a total of 13 inches. So I'm going to rotate 13, and it depends on how you guys want to draw it. Since this is just a sketch, we don't really know what quadrant it's in until we figure it out what the answer is in radians. So all I can say is this rotation is 13 inches. And it's going to end somewhere over here based on my drawing. This question wants us to find the number of radians. So they want us to find this angle right here. They want us to find theta because theta is always going to represent your angle. And in this case, they're asking us to find radians. So we just have to figure out where would the numbers plug into this tiny formula. Well, we know that 5 inches was the initial ray. And what we set up top is your initial ray is always going to be your radius. Because not only is it going to be 5 inches there, it's also going to be 5 inches here. No matter where we draw that line, it's always going to be the same distance as what we started with. So we know that's going to be our radius. So that will be our 5. And I guess I could just substitute it in underneath. I don't know what I'm doing. So 5 is going to plug in for r. S stands for the arc length. And we just said that the arc length is 13. So the last thing it wants us to do is just find theta. So after you plug everything in, we're going to see theta is really just 13 over 5, which you guys could reduce if you really wanted to. And we could say 13 divided by 5 is going to be 2.6. So in this particular problem, the angle is going to be represented by 2.6 radians. Sometimes, and I didn't do this to you guys on the homework, sometimes they would ask you to convert that into degrees. So you would just have to take what we did yesterday and multiply it by 180 over pi, and then you can convert it into degrees. I didn't do that to you guys on the homework. You just have to make sure you're reading what the question's asking. Okay? Because it says right here, Tabitha, it says, what would be the number of radians? So this particular problem is solving in radians. A lot of times in math, especially when you start doing trig, the answer will always be in radians unless it says otherwise. So if it tells you that it should be in degrees, then you have to make sure that you're solving it for degrees. But every time you use this formula, it will solve it in radians for you. So I'm going to do the same thing on exercise number 3, and that's all I got for today. So we got a little clock, and I don't know if you guys know of a pendulum clock. If I draw it out, it might make a little bit more sense. Pendulum clock is like one of those big like grandfather clocks. So let's say I got my little clock right here. A pendulum clock is one of the big grandfather ones where you actually have a pendulum that goes back and forth. Oops. So it's just one of those clocks where it swings back and forth, back and forth. There's only one. I should have drawn like a dotted line for the second one. So there's only one pendulum, but it's just rocking back and forth inside of the clock. So I just drew the picture. So we have our picture right here on the inside. I could blow it up on the outside here. This is kind of like what's going on here. So there's like a little rotation. And it gives us some information. It says that the pendulum clock swings at an angle of 0.55 radians. So this time, they're telling us what the angle is. And they're saying the angle is 0.55. It says what distance does its tip travel if it has a length of 8 feet. So the tip would be the bottom of the pendulum down here. They want to know what is the distance it traveled here. So we don't know this part. However, we do know the length of that pendulum is 8 feet. So in this particular problem, we need to figure out how much it's swinging in order for this to be a correct grandfather clock. So when we go to solve this out, we're still using that same formula as we did up top. It's that theta is equal to S over R. In this case, we were given theta, so we know theta is that 0.55 is equal to S stood for arc length. We don't know the arc length for this one because the arc length ends up being question mark. So I'm just going to leave that as S. All over the radius, which the radius of the pendulum clock was 8 feet. So in this particular problem, we're just solving it for S. And I'm hoping you guys are seeing these are just proportions. That's all we're really working with. It's just a fraction equal to a whole number. So I'm just going to put it over 1. And if I cross multiply, that should tell us how much the arc length is going to be. So I have 8 times 0.55 if I cross multiply, and it's saying it's going to be 4.4 feet. And we know this is going to be in feet because the actual pendulum itself was in feet. So we can't change the unit to inches or meters or anything like that. Okay? So as far as the homework goes for tonight, some of you guys may have already got a jump start on the front page of it. So the front page was doing all the conversions. And when you get to the back page, numbers 5 and 6 is what we just did today. So you guys would just have to draw the picture and use the theta equals S over R formula for both of these. I would recommend drawing the picture. Some of you guys may not have to, but if you draw the picture, then you may be able to see which number gets plugged into where a little bit easier. Okay? The only other thing, and the iPad froze again. The only other thing was on question number 4. Tabitha pointed it out to me earlier. I'll point it out to you guys as well. Is it working again? So on question number 4, I crossed it off. This, I didn't realize I had it in this question. They wanted you to convert it into degrees and then convert it back into radians. I just want you guys to convert it into degrees and then graph it. So I just crossed off this middle part right here. So all I'm looking for you guys to do, convert it into degrees first by doing the conversion we did yesterday. Graph it and find your reference angle. Like create the right triangle like we did on the homework the other day. Okay? Sierra, if you're still having trouble with those other 2 questions, just shoot me another email. Or you can stop by Zoom either tomorrow or Monday if you need to. And then if anybody else has any other questions, I mean, feel free to hit me up. Yeah, Sierra, just do that. Come tomorrow to the Zoom. I'll be there. All right, so that's all I got. Get those homeworks in. If you got questions, let me know. You guys have been doing pretty good at asking questions and sending me emails, so I did answer it. Okay. Other than that, no lesson tomorrow. Tomorrow's Friday. So remember, I'm not teaching lessons on Friday. Tomorrow's just going to be a makeup work day. So make up with whatever you guys need to do. I know some of you guys are still missing some assignments, but I know you're working at your own pace. So let me know if you guys need anything, and we'll go from there. All right? Have a great weekend if I don't talk to you guys tomorrow, and I will catch you guys all later.